Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on limiting and excess reactants. The last time we learned all about volume and volume relationships. We defined molar volume and learned how to solve volume problems. In today's lesson, we are going to define limiting and excess reactants. We will show that the amount of product produced in a chemical reaction is based on the limiting reactant. Let us begin our lesson. When all of the reactants in a chemical reaction are completely used up, the reactants are said to be in stoichiometric proportions. However, these types of chemical reactions do not always occur. In many chemical reactions, there is too much of one or more reactant and less of another. Thus, if there is less of one reactant, it will be completely converted into products. A reactant that is completely consumed is referred to as the limiting reactant. Students, let us do an activity. Why are reactants that are completely converted into products referred to as limiting reactants? Please choose the option that best answers the question.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If you chose answer B, good job. Reactants that are completely converted into products are referred to as limiting reactants because they limit the amount of product that can be formed. Let us move on with our lesson by looking at an example. Students, please look at this equation. In this equation, 1 mole of hydrogen reacts with 1 mole of chlorine to produce 2 moles of hydrogen chloride. Thus, all the reactants have been consumed, and all that is left are the products. However, if 1 mole of hydrogen were to react with 1.5 moles of chlorine, there would not be enough hydrogen to react with all of the chlorine. There would be an excess of chlorine, and hydrogen would be the limiting reactant. We would still get 2 moles of hydrogen chloride, but we would also be left with 1/2 mole of unreacted chlorine. When there is too much of a reactant in a chemical reaction, we are left with some of it after the products have been formed. We refer to this as an excess reactant. There is an excess amount of the reactant that cannot be reacted because there is a limited amount of other reactants. Let us look at another example. This is a beaker filled with about 50 milliliters of methanol. As the methanol burns, it reacts with oxygen in the atmosphere to form the products carbon dioxide and water. However, the reaction only happens where the methanol and oxygen can contact each other. If the beaker is turned on its side, more methanol becomes exposed to the oxygen, and the reaction becomes more vigorous. Students, let us do another activity. In the reaction we just discussed involving methanol and oxygen, which reactant would be the limiting reactant and which would be the excess reactant? Why?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. You were correct to say that methanol would be the limiting reactant and oxygen would be the excess reactant. In this example, there are only about 50 milliliters of methanol. However, the amount of oxygen present in the room could have been very large. Therefore, methanol would be completely consumed in this reaction to create the products carbon dioxide and water, while an excess amount of oxygen would still remain. Students, let us look at another example. We will determine how much ammonia can be produced when 10 grams of hydrogen reacts with 18 grams of nitrogen. The first thing we have to do is determine how many moles of each reactant are present. We do this by dividing the amount of the reactant in grams by the number of grams of each reactant that are present within 1 mole. For hydrogen, we would divide 10 grams by 2 grams, which is the amount of hydrogen that is equal to 1 mole. Our answer is 5 moles. For nitrogen, we would divide 18 grams by 28 grams, which is the amount of nitrogen that is equal to 1 mole. Our answer is 0.64 moles. Once we have done this, we can calculate the number of moles of product that would be formed by each reactant. The reactant that forms the least amount of product would be our limiting reactant. For hydrogen, we divide our 5 moles of hydrogen by 3 moles because our equation involves 3 moles of hydrogen. This is equal to X divided by our 2 moles of product. We then cross-multiply the 5 moles of our reactant by the 2 moles of our product and divide it by the amount of reactant we started with, which is 3 moles of hydrogen. This allows us to solve X, which is 3.33 moles. Then we multiply X by 17 grams, which is the amount of ammonia equal to 1 mole. This gives us our answer of 56.6 grams. This is how much product our hydrogen reactant produces. If we repeat this process with our nitrogen reactant, we will discover that it only forms 21.8 grams of product. Therefore, the nitrogen is the limiting reactant. In today's lesson, we learned the difference between a limiting reactant and an excess reactant. We also learned that the amount of product formed by a chemical reaction is based on the limiting reactant. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.